Hey, French Sardo, hello. That's an interesting name. So, yeah, getting started. Doo-doo-doo. Hey, thank you for the $5 donation to the Software Foundation, man. Thank you. That's truly appreciated. Thank you very much. That reminds me, I should turn this stuff on also on YouTube. I should turn this stuff on also on YouTube. Okay. I guess time to do social media. Okay, let's see. Are we actually live also on YouTube? It seems we are. Okay, cool. Well, hello everybody. So I just started the stream, so give me a sec to get settled in. I'm gonna go make some tea. So, but as like a recap of what I want to work on, I did some like off-stream work on the parser. So yesterday what was happening is that I was messing around with the tokenizer, with Johnny Marler's tokenizer, made my own parser for it. Then at some point I started kind of wondering whether what I was doing was in any way meaningful, because I mean the stuff that I was doing was so straightforward that at some point I started wondering whether there was actually anything to gain from using Triciter, and then maybe I could just do some more validation on, improve the validation on the Triciter 3. But then I looked at it in the Triciter playground and I realized that Triciter is it parses things. It does some weird form of parsing that really behaves in a bad way when there's like bad syntax, from the perspective of producing diagnostics, at the very least. Like maybe you can make arguments for syntax analyzing. I'm actually weirded out about that too, but in any case, so yeah, no, conclusion, the work that we're doing is ultimately it's a bunch of work to land back to a like fairly normal parser, nothing particularly special about it, but still probably will behave better than what Triciter does. And so yeah, we're going down that path. Like some more stuff needs to be done, add support for things. The feature that I'm most excited about right now is implementing auto formatting. So the ability to detect white space and to tweak the white space in order to achieve a canonical representation of HTML that properly accounts for what you can change as the auto formatter without impacting the semantics of the HTML, and what you cannot change. Because apparently this thing is not done correctly, not even by the goddamn HTML LSP that comes with VS Code. So let's try to do better than that. So that's the plan. Okay, I'm gonna go get some tea. I had coffee earlier, but I'm gonna have some tea as well. Oh, happy coding section. Well, thank you, X9Moo. Sorry, I have no idea how to pronounce your actual nickname, but I'll go with the Twitch handle. So thank you very much. I'll be right back. Give me like a couple minutes. Hello, I'm back. Hello, hello, hello. Hey, cancer name on YouTube. Average Lorry stream. Yeah, watching the chair, you mean? Yeah, I mean, what can you do? Such is life. Listen, here's how it works, okay? Real talk, kid. When you open a stream, it's like I'm waiting for my 1,000+ viewers to show up. That's all I'm doing, pretty much. Okay. In any case, you know what? It doesn't matter. Like, whatever you say doesn't matter. You know what matters? Emoji reactions. That's where the true story is. So unless the emoji reactions say that you know, what I'm doing is not okay, then it means that the majority of people actually agree with me. I really can't forget this quote. Jesus Christ. I think I went to sleep thinking about it. Yo, Zig user followed. Man, okay, like you made a Twitch account named Zig user. I hope you like the language. Or well, I'm guessing it is because of the language. Man, if you end up not liking the language, I guess you'll need on your account. Does that mean the Emoji Movie is the best story of all time? You know what? It might actually, well, maybe not necessarily best, but certainly the truest, right? It may very well be the only one true piece of history that we ever experienced. Maybe, you know, it might be that, I mean, everything is a lie, probably. You know, history, dinosaurs, Jesus. I mean, can you actually trust any of this stuff? Has there been any, is there any recorded, like, trace of emoji reactions with regards to these things? I don't believe so. So, can trust anything. They're all equally fake. Easy user. Thank you for the tier 1 sub. Of course you love the language. Nice. Well, I hope that you continue loving the language going forward. Otherwise, that's one Twitch account you can throw in the trash. I don't know. Maybe you can change your nickname. Okay, so what are we doing? You know what? I should do also like the big streamers do. You know what? Let me do it. I'll do like the big streamers do. You know how... so I hope people here also do watch Twitch in general and not just watching this stream. Actually, I don't know. I said I hope, but honestly, I don't know. Whatever. You do whatever you want. But know that the big streamers usually have like a small number where their camera is that tells people how many subs they have. So like you can watch, I don't know. Let me think of one good example. I don't know, like Summit 1G. How many does people here, do people here know how many subs Summit has? I think it's like 10,000 maybe. Actually, you know what? I'm not even sure at all. I think I saw this stuff at some point, but it's been a while, and the current number might be wildly different than what I remember. Yeah. So let's see. Holy shit. That's 23,000. 23,000 subscribers. Do the math. That's a good chunk of money every month. Francis Aldo, thank you again for the other $5 to the Ziggy Foundation. Thank you. So, oh, you don't? Well, in any case, so he's not the only one that does this. Like a bunch of people do that. I should do it as well. You know what? Let me let you guys into the secrets. Let me see. New text element. Subs count. Let's see. Arst, move to the right position. Lower, make smaller. Okay, get ready. Here's the actual number. Boom. 7. That's it. That's That's how it is. I don't play games. You know what? Maybe if I played games, that number would go up. Maybe I should play games. Let's see, it didn't even occur to me that Tree-Sitter would be a good source of information on how to parse HTML. Tree-Sitter is very versatile. Like, my recommendation would be, if you're trying to, kickstart something that requires one or more parsers, it's definitely a good place where to start. But as you're trying to refine the thing, depending on the user or on the use case, you will find that Tree-Sitter has some serious limitations. So my experience with Tree-Sitter was that, let me start with that. First of all, Tree-Sitter is not just like one parser, but it's a parser framework. It's I guess you could say a parser generator. So Tree-Sitter has a bunch of Tree-Sitter specific language specific grammars. Like Tree-Sitter JavaScript is the grammar for parsing JavaScript using Tree-Sitter, and you express these things in a JavaScript file. Yes, to use Tree-Sitter, you use JavaScript. Why wouldn't you use JavaScript? Obviously, it has to be JavaScript, right? What else could it be? In any case, you use JavaScript to define the grammar, and then from there, you get basically a C parser that gets generated from your JavaScript grammar. And that's what gets compiled to a dynamic library usually, and in general used by various systems like your editor. So it's very versatile, and for example, it's pretty good if you want to get syntax highlighting, for example, into something. Like, you want something to be able to support syntax highlighting for, code snippets, for example. In my case, I'm writing a static website generator, and I want to generate syntax highlighting statically. So I could, in theory, have my static site generator, plop in just the source code and then use some JavaScript library. Instead, I like the idea of having this stuff happen while you generate the HTML, so that you don't have to do this at runtime in the browser. And I use Tree-Sitter for that, and it works. It's really, really good. And also, if you're coming up with a new language of any kind, you will need a Tree-Sitter grammar for editors. So plenty of reasons why it is not a bad idea to get acquainted with Tree-Sitter. It is good, but man, once you're at a point where you want to have like good diagnostics for something, like a language that you're making, and then you want the parser to have certain properties when dealing with malformed input, because that's pretty much what you're doing all the time when you're looking at like when you're analyzing something that is being typed. Obviously, as the user is typing it, the thing is going to be malformed. So once you get to that point, Tree-Sitter is going to leave you in the dust because it's not going to behave particularly well. So you're going to need to make your own. And there's a bunch of complexity there too, because the way, like the basic way of writing a parser usually means that you find one error and that's where you give up. Like, you find something that doesn't make sense, and that's where you stop. You say, look, there's an error here. Everything before then maybe made sense, but now did make sense, at least up to a point. And then we got here, and then things went wrong, and I don't know anything about the rest of the file. Problem is, you cannot do that with LSP. With LSP, you have to recover. You cannot like completely give up the instant you find like a missing colon or a missing semicolon. And that's a property that as a user you expect from your tuning, from like your editor. So Tree-Sitter at that point falls apart, and you have stuff. I like if you want some reading on these topics, take a look at what MathCloud has blogged recently. There are, I think, a couple interesting things to do. You Be My Bear. Oh, I did not read this one. LSP could have been better. Yeah, it definitely could have been better. That is for sure. Where is it, man? Wait, what the heck? Where did that blog post go? Like, I'm way too in the past. I think it's from like late 2023 or even 2024. Oh yeah, here. Oh my god, sorry. I was blind. Yeah, the resilient allowed parsing tutorial. So here, for example, MatClad. By the way, MatClad is the guy who made like Rust Analyzer. So that's like the LSP for Rust. So he knows about this general problem space. And like the way he suggests to write the parser is, it's like really non-trivial. Like basically you're not going to do any of this shit unless your specific goal is to make an LSP work. And even then, this is one approach that he suggests, in his opinion, is better than other approaches, which are more like, he calls it resilient. Some other approaches are more about recovering. So like a recovering parser basically tries to build a normal, well-formed AST, but then occasionally it might decide then to throw away some tokens that make no sense. It might decide to mark something as missing. So for example, you could have like a piece of text, but the semicolon is missing, and like that semicolon is expected to be there. It's not. But then if you kind of assume that it should be there, which is usually something that you can do safely, especially when you have some kind of redundancy in your language, so you can assume that it should be there even if it's not, and then hopefully everything else will kind of fall into place. Sometimes it does, sometimes it doesn't. But so that's like an AST that tries, like a parser that tries to recover. A resilient AST instead, well, I don't know if he calls it resilient AST, but like a resilient parser instead produces ASTs that can also have shapes that are like unexpected. Like let's say that you have a key value thing, like your entire language is like just key value. So you have name equals something else. Like think of it as a like super dumb YAML. So key value, and at some point maybe you have, so for example, you have name white space equal sign and then the value. So there it's a case where like a missing equal sign, you can mark it's missing and say that if you have like token space token without equal sign in the middle, you can assign one to key and the other one to value, and maybe it works out. But what he's suggesting instead is to not assume that the AST is always going to come out as key value pairs. Maybe you will decide that you will have like a node where you have key and then a value. In a case of a language that is just key value pairs, it seems silly because it's a super simple case. But when you're looking at more complicated languages, at least according to the argument that he makes, it makes more sense and it's more available. And I don't know, I felt like when reading this, it made sense to me. So in any case, point being, there's a lot of stuff related to parsers and tokenizers and shit. So yeah, make a game and play that. Yeah, maybe I should do that. I like Twitch a bit more if they split game dev from software. Otherwise, it is YouTube pods. Yep, I do call Mac. I just do normal call Mac though. No DH, no weird other exchanges. I don't know. I think it's fine. Honestly, I don't have a strong opinion. I also think that call Mac is like better than QWERTY, but not all that better. It's like it's fine in my opinion. But frankly, I wouldn't have switched. Like, I don't think it's worth switching if what you gain is just what you gain from Colimac versus QWERTY. For me specifically, I never really learned how to touch type well. And so doing it from scratch again, basically I went from PD QWERTY to good Colimac. And at that point, it really made sense for me. What is Terminal App? Never seen that icon before. Oh, that's Ghosty. Pretty nice name, huh? Ghosty with a double T. Ghosty the Y. It's a terminal emulator written in Zig by Michel Hashimoto. Right now, it's a closed beta. So to join Ghosty, you have to like Google Ghosty Hashimoto, I guess. And you will find Michel Hashimoto's blog. He has devlogs about Ghosty, couple talks, one on my thing, on my YouTube channel, another one on some... Actually, no, this other thing is just a blog post, I think. Yeah. And in there, you will find also links to the Discord server. Like you click this one, Okay, I don't remember exactly where, but some of those have links to Discord, and you can join the Discord server. And by joining the Discord server, you get a chance to get invited into the closed beta. If you don't like going through these hoops, you don't have to do it. In any case, the closed beta is like really mainly for, have people test drive the thing and iron out bugs. But I think it's gonna open sooner than later. Like, I feel like Ghosty made so much progress and is so solid now that, I don't know. I don't expect it will take long. In any case, what Mitchell tends to do is like, have a wave of invites, have people try the thing out, have people open issues when they encounter a bug or their workflow is not like perfectly fulfilled by Ghosty, and then he solves these issues, and then when there aren't any more issues, he then makes a new wave. So that's how it works. But yeah, really. I'm definitely checking out Matt Glad's blog article on this. I enjoy what they wrote on UB. Oh, I did not read that one. Like, I opened it in another tab, but I didn't read it. Hey, Matthew. Good day. Good day to you. Yeah, there's also this thing about, like, this is another thing. That's a good point. Like, Colimac versus Colimac DAH, it becomes even harder to get compatible. And I would argue that while Colimac is better than QWERTY, you should factor in the fact that you are not going to be compatible with other humans anymore once you switch to Colimac, or like most of them at least. And in my opinion, that's where I feel like it's not really all that worth it, unless you really have a lot to gain, which in my case I was a shitty QWERTY touch typer. So, yep. Okay. Let's see what McLeod has to say about UB. A short note on undefined behavior, which assumes familiarity with the subject. See this article for the introduction. The TLDR is that I think that carrying the wording from the C standard into newer languages like Zig and Rust might be a mistake. This is strictly the word choice, the lexical syntax of the comments argument. The C standard leaves many behaviors undefined. However, it allows any particular implementation to fill in the gaps and define some of undefined in the standard behaviors. For example, C23 makes realloc pointer 0, so a zero length reallocation, into an undefined behavior. Why? So that POSIX can further refine it without interfering with the standard. Okay. It's also valid for an implementation to leave UB undefined. If a program compiled with this implementation hits this UB path, the behavior of the program as a whole is undefined, or rather bounded by the execution environment. This is not actually possible. It is not actually possible to summon. Yeah, this stupid fucking thing that people keep repeating. You know what? The fact that people keep repeating this thing, like whenever I hear somebody mention this, my first gut reaction right away is this person has no idea what they're talking about, and they just repeat what everybody else repeats because that's kind of the depth of their understanding of the situation. Obviously, it's not going to be factually true for everybody, but man, it's one of those things where I really feel like if you're repeating this shit, then you're not helping. You're really not helping. Like, the reality is that like this as a joke is like, it's fine, whatever, but the fact that people repeat it so much every time there's a discussion about UB, that like you're not helping the listener learn anything. So you're like withholding, in a sense, information to them and potentially to yourself by sticking to this kind of shit. Sorry, in any case, quick break. Phasing. Thank you very much for the Prime sub. Thank you. And you know what? Guess what? That's an 8 now. Can I like lock this but then still edit it? Yes. Okay, cool. OBS moment. Okay, because a user space process cannot escape its memory space other than by calling syscalls, and there are no nasal demons summoning syscalls. Thank you, Matt. That's a good point. Yes. I also feel like this, like leaving it at that, kind of precludes what I feel like is my definition of UB, which I will give you all in a moment. Oh, you did do that, Matthew? Sorry, I didn't follow it all. Did you do that? That's bad. You know what? The specs guy promised a UB talk at some point, but he's like, he hasn't done it yet. I think he's worried of getting it wrong. Maybe I will make my, you know what I'll do? I'll make my own UB talk, which is gonna be bad. Just to elicit, just to, you know, make him do his. Anyway, C implementations are not required to, but may define behaviors left undefined by the standard. A C program written for a specific implementation may rely on undefined by the standard, but defined by the implementation behavior. Like this is, well, yeah, this is obviously fair. Like the instant you have something that is not fully defined, then whatever implementation, if one specific implementation keeps doing one thing whenever the thing happens, then people start relying on it if they want to. Sometimes that's fine, sometimes they're not as fine. Modern languages like Rust and Zig reuse the undefined behavior term. However, in the intended semantics is subtly different. A program exhibiting UB is always considered invalid, even if an alternative implementation of Rust defines some of Rust's UB. The programs hitting those behaviors will still be incorrect. For this reason, I think it would be better to use a different term here. I'm not ready to suggest a specific wording, but a couple of reasonable options would be non-trapping programming error or invalid behavior. The intended semantics being that any program execution containing illegal behavior... Oh, he switched from invalid to illegal. Is invalid under any implementation. Curiously, C++ is ahead of the pack here and has an explicit notion of ill-formed, no diagnostic required. Update. I've since learned that Zig is updating its terminology. The new term is illegal behavior. This is perfect. Illegal is just the right connotation of being explicitly declared incorrect by written specification. Let's see. I also basically don't touch type. My typing habits are bad. Perhaps I should sit down and learn another layout at some point. Matthew, honestly, I would recommend this. Do that at some point. I think you will have a good time. Well, no, you will have a super shitty time for like a month. Between 1 month to, well, let's say more or less a month, you will not have a good time. But I promise you it is worth it. I would also recommend to do that, not just from a productivity perspective, but because joint pain, it will come for you as well. This is not like an if, this is a when. And if you, if you minimize the strain on your joints, it will come later than sooner. So this is like, it's like the, what is it, Puss in Boots thing, where death is coming, you can't avoid it. It doesn't matter, like you can act like you don't care, but it's coming, and you're gonna be scared when that happens. There is no doubt there. So I would recommend that. And at that point, you have a choice between, mainly Dvorak and Kolimak, or you can go for something, more funky like Workman. Personally, I don't think it makes much of a difference. They're all decent. Pick the one that you think it's gonna be best for you. Personally, like if you want like a recommendation, but as I said, I think they're all fine. I would recommend Kolimak personally. Andrew does Dvorak, for example. So Andrew does Dvorak. iFreund does Kolimak. GW1 does Kolimak. I think there's a few. I think we have more Kolimak people than Dvorak. Anyway, let's go back to the UB stuff. Let's see. So here's my interpretation of. Here's how I reason about UB. Okay. Here's the problem. You. The reason why you want to leave something not fully defined is because that specific thing doesn't map well to the underlying machine that's going to do the operation. And so you want to leave some wiggle room for allowing you to express something in high levels and say that some of the things there can be, you know, the definition of what you express is not completely fully locked down. There's some wiggle room that allows you for performance improvements potentially. And so then you have this problem though, where if you then do one of those things that you're not supposed to do, then you get undefined behavior. But undefined behavior, it's not like as Matt points out, it's not like actually completely arbitrarily anything. It is actually a set of possible outcomes. The problem is that set of outcomes, it's going to be complicated, and it's not going to be easily to define within the semantics of what you are defining, kind of by definition. So like, let's say that you have invalid memory access, which like you read and branch on memory that is dirty. That's UB. But the actual possible outcomes from that is actually a limited set. It's huge. It's going to be a huge set of potential outcomes, but it is limited. The problem is that it's so hairy, that set of possible outcomes, that it's not going to be practical for you to define it in terms of the language itself. Like the reality is that if you read garbage memory, then and like you branch on it, then you will branch based on whatever garbage was there. And so what is the garbage that was there? That depends on other things in the system, but it's not going to be magical. It probably maybe could even be somewhat randomized to some degree, but it's not impossible to know. It's just so hairy that it is not worth defining. So that's kind of it. And then, but this is a spectrum. Like even then, your UB sometimes is highly unpredictable. Sometimes it's very predictable. And when you have very predictable UB, that's when you have people relying on that predictability and then just using it as a feature, which is what MathCloud is pointing out. So that, to me, that's kind of where you are. And it's like, should you have UB? Should you not have UB? I guess it depends. Do you want optimizations? If you want optimizations, I think you need the UB. If you don't want optimizations, then you can probably make do without UB. But then you have Python, and so your game is not going to be nice if it's Python. Andrew's keyboard layout was funny. Was trying to add a note to the workshop slides on his laptop. Oh no, yeah, that I do the same thing. Like when people touch my laptop, they have the same problem. The Mac has like a nice shortcut for switching layouts. It's not even a shortcut. It's a dedicated button that allows you to switch layout. But I have rearranged my keycaps on my MacBook according to the Call Mac layout. So either you know how to touch type QWERTY confidently on that keyboard, or the moment you look down, the thing will lie to you like terribly. Let's see. I have wrist pain from typing 13 hours a day. I didn't touch type, but getting a keyboard that slants inwards and playing the typing of the ironically helps. Yeah. I have this one. It's the Advantage 360. Holy shit, that thing is good. I tried some like custom, more custom built group buy kind of keyboards, which are great in many ways. But this guy beats all of them, hands down, in my opinion. And it is great. For me, what really helps me with wrist pain is going to the gym. Going to the gym, like weightlifting, that kind of stuff really helps me. I don't know. That's like just my situation. Anyway. Actually, and so one last thing to say about this blog post. So since UB is basically something that it's like some wiggle room that you wanted on purpose to leave in your spec, but then has the downside of when that happens, it is hard to describe what are the possible outcomes. Sometimes it's easier, but then you have the C thing. But at this point, the decision of defining like the act of you relying on UB and defining that as not okay, ultimately it's like it's a cultural choice. Like C could have very well been, as a language and community and like the practices around C, they could also have decided to consider relying on implementation defined UB a bad idea, but they didn't. So I sorry, this is not like criticism. It's not like Marklad is saying that's not the case, that shouldn't be the case, or what. I'm just pointing out the fact that it's like it's up to you. Like Zig in theory could be more friendly towards relying on implementation behavior or implementation defined behavior, but the reason why it is not, I don't know how hostile to that Zig is, honestly, but the reason why it's not particularly friendly towards it's mainly because we care about cross compilation. And caring about cross compilation means that you know, this shit has to be defined somehow. Otherwise, the cross compilation is not going to work. Otherwise, the comp time VM that tries to emulate the target system will not know how to do that, or will not do that precisely. So, if you care about cross compilation, then you're probably not gonna look at relying on implementation defined behavior particularly as a particularly smart thing to do. So for example, there's a lot of C applications out there that rely on the assumption that allocators give you maximally aligned memory all the time. Like whenever you ask for a chunk of memory, you always get aligned memory. But for example, which is how can I say? Which is fine, I guess, except when it's not, because then you write code. Oh, sorry, I talking about allocators giving you always aligned memory. That's part of it, but that's not the problem. The problem is that alignment is not part of the type system, and so sometimes you deal with unaligned data, especially because in C people like to, you know, pack stuff together and produce like weirdly byte aligned data types, which might be fine on x86, but then it might not be fine on another architecture, and they just don't care. While in Zig, since this cross compilation and like different platforms tend to be more front and center with the style that you're supposed to use in Zig, then that type of bit packing, well, I should say more byte packing, that type of byte packing becomes more problematic. Like the language will ask you to write more stuff, and it will ask you to handle all this weird alignment shit explicitly. For example, I was looking a while ago at a long while ago, probably was like at least a year ago, but I was looking at Anti-Rats Rax. I think it was called Rax. Yeah, it's a Radix 3 implementation that Anti-Rax made. It's fine. It like I think there are other implementations that like take it even further, like do weirder bit packing stuff. But in any case, here a node has a bunch of things that have different meanings depending on other states, and at some point you do get, if I remember correctly, some weirdly aligned numbers, and that's fine. And that like you can do this stuff very easily with C. It works. It works. But Zig makes it harder. Zig makes it harder because in reality, this thing, like this, the I don't know, not just the performance, but like the way the machine is gonna behave with this implementation will change depending on how it deals with alignment. And so I remember that like porting one line of this thing to Zig, it wasn't a one-to-one mapping. Let's just put it that way. Gregory Z asks on YouTube, is this going to be a LXML replacement? No, not really. I'm just writing my own HTML parser for my own templating language, for my own static site generator. So that's kind of the main goal. Then if this becomes like reusable for other people, great. But that's not what I'm worrying about right now. Anonymous Gifter gifted a tier 1 sub to Trump is your mom. Well, thank you. Also, Trump is your mom. Enjoy. And guess what? Wow, we're at 9. Holy shit, man. Yeah, I'll become Summit 1G in no time. This way. Okay, so here's the plan. The plan is, let's do some actual work on the HTML parser. And you know what? I was mentioning earlier what the goal is. So I'll tell you what the short-term goal is with this stuff. And then we do some work. And I don't know, then we decide what to do afterwards. So the idea is this. Right now, this first test I can pass. And let me tell you what's going on here. Here I have my AST that I init, and then I ask, and then I render back. So the AST knows how to render itself. But what's interesting is that I then compare the original source code to the rendered AST. And when there is no white space between tags, we also do the same, right? Or rather, right now the AST doesn't render any white space, isn't aware of white space pretty much at all. So we basically render any AST into a single line without new lines, without spaces, like this. The next thing that I want to support is auto formatting. So I want it to do new lines and indentation correctly, but doing that requires some nuance, because doing that correctly requires realizing when there is white space between elements and when there isn't. Like the fact that this, well, maybe for head it doesn't matter much, but like the fact that this div doesn't have any white space in it, that does make a difference in the rendered output. Ignore for a moment the link element in it. Imagine that there is some text. Having space like leading, like at the beginning or the end of this internal text, having white space there does make a difference. So because of this, what we want to do is have the auto formatter realize when there already was white space. So that means that the white space can be, you know, once you have white space in XML, in HTML, you can add more spaces, you can add new lines. It's not going to change anything. So that's what we're going to do. White space already present means auto indentation. White space missing means we keep the tags attached to one another. We do not introduce any white space. Third thing, that is true for everything except pre-tags. Pre-tags, for in what's inside of pre-tags, like all the white space inside of pre-tags is meaningful. It gets rendered by the browser as is. So we are not allowed to mess with the contents of pre-tags. So that's kind of our to-do list. Lastly, well, on top of that, we also kind of want to introduce, smart behavior when it comes to attributes, where the idea is we want to introduce the ability to split attributes on multiple lines and undo that using leveraging the auto formatter, kind of like it already happens in Zig. Happy Man. Are there Zig developers in India? I don't know. I'm sure there has to be somebody in India that has heard of Zig and has done some things with Zig. So I don't have any specific, I don't have any concrete example in mind, but statistically speaking, somebody has done it. Do they like work with Zig or more seriously or what? I have no idea. It's still kind of early, so there aren't all that many Zig jobs out there. But there are, I think, quite a few people who are like sneakily using a little bit of Zig at work, not too much, and that's it. So that should be that happens. India developers are hired by American companies for very less pay. Yeah, such is life. That's true for India. That's true for pretty much everywhere in the world, everywhere else in the world. HR likes to try and give you a salary based on your cost of living. Sometimes you don't have the negotiation position, the negotiation power to stop them from doing that. Sometimes you do. It depends on which position you're in. Obviously, they're gonna try to use every excuse to pay you the least they can get away with paying you. Like you can't even fault them. It's obvious that that's what they're gonna do. Sometimes you can prevent that, sometimes you can't. Such is life. Oh, Zig user sneaks Zig at work. How did you sneak Zig at your work? Like, what do you use it for? What is your work in general, if you can share? In the meantime, what I was doing earlier was having the tokenizer produce information about where the diamond brackets are inside of a tag, like an opening tag, a closing tag, or like a start tag or an end tag of an element. And I'm basically wiring in that information, and then I'm going to use that to reason about white space in the renderer. Okay, let's see. What was he doing earlier? I'm in the AST, and oh yeah, I was looking at this algorithm. So I find a closing tag. The question is, if I'm already in the root, like there was no element at all, and I find a closing tag, then I'm gonna complain that it's a weird closing tag, like a weird end tag that isn't closing anything because nothing was open before. So that's one. Then we need to start going up and find where that closing tag actually matches. And as we go up, if we encounter root, that's when we do the same error. Well, like the root thing didn't happen right away. It happened as we were going up. We restore the original position. I think this is different now. This is not LHS. LHS doesn't exist anymore, so we need to change this. This is going to be... Oh, this is interesting. Okay, so what we have here... Oh, span can do slice. Oh, that's perfect. So that's going to be current dot open dot slice. And I think ET, actually ET is going to be a end tag. What's an end tag? It's a struct that contains all bracket and span, so never mind. We do want the span here. Oh, but the problem, okay, I'm starting to realize what the problem is. The problem is that, well, guess what? For the open tag, we don't remember anymore what just the name is. Now we have the full tag. Oh man. What will be the use of this HTML parser? This is it. Borg send zine ssg.io. Check that out. It's my static site generator, and I have my own custom templating language. It already works. It's like not super high quality. It's like POC quality level. Like you can make simple websites. You can add some logic to them, but some things are not implemented yet, and the error reporting isn't all that great. So what I'm doing right now is the current implementation uses 3-seater as the HTML parser, and I'm throwing that away in favor of my own implementation because 3-seater isn't great at producing diagnostics. Let's see on YouTube. Happy man. Rust is becoming exponentially complicated. Instead, Zig is better alternative. It should... Oh my god, there's this emoji thing that is covering some text. Who designed this shit, man? Why did they design it this way? God damn it. Oh, there we go. I think it is a better alternative. It should contain some operator overloading. That's debatable. So you're just in the same sentence. You told me that Rust is becoming exponentially complicated, and then you're also asking for new features to be added to Zig that would increase the complexity. I don't know. I don't think operator overloading will ever be a thing in Zig. What I would consider is still a bit of a more open question is matrix stuff. Like I can see some kind of solution happen at some point for matrix stuff, for matrix operations and related like matrices, vectors, that kind of stuff. But other than that, I don't think Zig will ever have operator overloading. The problem with operator overloading is that it really hinders your ability to reason about code locally. because you see A plus B, and now what A plus B is exactly, it's a whole different thing compared to, you know, not having operator overloading. And in any case, whatever operation you're gonna implement, you can still use functions for that. Sure, maybe it's not gonna be as readable depending on what you're trying to do, but like you can still make do. It's not like a deal breaker for real. Let's see, Zig user, DevOps engineer, wrote a service agent for log exports to S3. Nice, simple, fast, and definitely easier to handle multi-line log stitching over Fluent Bit or D. I don't know what Fluent Bit or D is. Wait a second. Easier to handle multi-line log stitching over Fluent Bit or D. Are these like other solutions for this kind of problem? I don't know. Sorry, I think I'll need you to give me some more context. In any case, that's cool. So log exports to S3. So you're basically using the S3 APIs, I'm guessing, to upload stuff to S3. Operator overloading is one of those things that sound cool on paper and are very unpopular among your colleagues. Yeah. Right. You know, when all your colleagues hate operator overloading and you don't, it's kind of like it's your fault. Chances are that it's your fault then. So base low level cultist. Well, you know what? I don't think that this is necessarily a universal truth. Like the issue with operator overloading. Like I think it makes total sense to have a ton of languages with that feature. I just don't think that every language should have it, because as a feature it's useful, but it comes with a cost. And while it might be totally, you know, worth the cost for most languages, it makes sense that out there are some particular niche, if you will, nicher languages for which it makes sense not to do that. And like it makes sense for different things to exist, right? Like pizza is good, pasta is good, but it does make sense that there are like cuisines out there that just don't focus on carbs all that much, as an example. So you need only to look at how operator overloading is abused in C++ to conclude that it's really a really bad idea in a systems language. Do you implement the actual HTML standard or simple parser? It is more than a simple parser, but I on purpose do not implement the HTML standard. I want to diverge explicitly. I'll give you one example here, okay? In HTML, you can write this. You can do this, h1 to h1, and then like this is all you have. This is the only content in your HTML file, okay? This is valid HTML. What happens is that this is actually an h1 that opens, that contains foo and another h1, and then both tags implicitly close. You can even have something like this. So this is still valid HTML, because in HTML, you don't have to close tags. In my case, I will consider this a build error or like a syntax error. I will tell you that because the reality is that when this happens in handwritten HTML, this is what happened. Like you forgot the slash, so you forgot to close the h1. But even if the tags don't match, like even if this is an h2 and your genuine intent was to have an h2 nested inside an h1, if you don't close these tags, I will still complain. You need to close your tags. So, long story short, my parser will not be exactly standard compliant. It will be standard compliant where it matters, but in key situations, it will not behave the same way. It will reject inputs that would otherwise be fine. But the reason is, like, not closing your HTML tags is stupid as fuck. Nobody really does it. If you do, fine, you do you. This tool is not gonna be for you, because the reality is that most of the time it's just like a mistake. You forgot the slash in your end tag. You can discourage that, but people will always do it. But have you considered use the thumbs up on your issue to decide how your use base want your HTML parser to work? I have considered that. Yes. The thing is, you know, right now I don't have all that many reactions, so that means that I can still choose what is the truth or not. You know, one day maybe Zin will be popular enough that I will have to bend to whatever the emoji gods say. And, well, you know, we'll see once we get there. For now, I'm still a free man. I should have been a bit more specific. We use ECS. And yeah, FluentBit and FluentD are services that can process std out or fs files. Oh, okay. So FluentBit and FluentD. So that's what you meant with the D. Let's see, Fluent. Sorry, I'm not like I understand the general problem space, but I'm not familiar with specific to observability tools. Super fast, lightweight, and highly scalable logging and metrics processor and forwarder. Okay, so like you, I guess, you spin up the daemon, you probably configure it with like ingestors and sinks, and so like you ingest stuff. Maybe you have processing rules for like adding prefixes, stripping things, filtering other things, like decorating and filtering, and then this stuff gets sent to a bunch of like sinks, I'm guessing. Yeah, input data source, logs, whatever, tag, record, filter, buffer, output. Yeah. Man, I remember at a previous job, people used to. What was the common thing that people used back when most stacks were like based on Elasticsearch? I think there was a thing that did this kind of thing that was very often used in combination with Elasticsearch, but I forget its name. I think I used it at some point. I don't think it was FluentBit though. I'm guessing FluentBit is probably the latest hotness. Man, I forget the name. Oh well. Okay, let's do a little bit of coding. So here's the problem now. Okay, we have a token, and that token is gonna tell us. Oh yeah, Logstash. Thank you. Yeah, it was Logstash. Yep. So we have the tag that's gonna contain the actual name, but our current node lost that info, which is annoying. So we need to recreate that info for the current node. We need to retokenize. So let's do that. So current name, I guess we can make a block for it. So we create a new tokenizer, and then we feed it. We feed it our slice. So we do const. I think we can even break right away. BLK t.next. Source is gonna be current dot. Oh well, we need to define that. Wait, what am I doing? I have slice. Oh my god. Yeah. Okay, so we have this. And then we... what am I doing here? We break this with t.next tag. Dot... question mark. Because... it shouldn't be null, it shouldn't be an error, it shouldn't be anything, but it should be dot start tag dot span source. Okay, So we retokenize, and this is going to give us the current name. Yeah. Okay. Okay, so this should be better now. I don't think we're building yet, though. I was basically trying to get back to a building state. I'm not there yet. Local variable T shadows capture from outer scope. Fuck. What's the T then? Oh, it's the token, right? That makes sense. That makes sense. Oh, that's also temp talk. Hey, Egoist. Hello, hello. Yeah, I am doing well. Thank you. Thank you, thank you, thank you. By the way, anybody watching, if you have Zig questions of any kind, feel free to ask. These streams are mainly to answer questions about Zig and a chat about Zig. I do have some work to do, so I'll do it. There's nothing to talk about. But if you have questions about Zig, I'm happy to answer them. Keep in mind, they say there are no dumb questions, and I won't go too hard on you, whatever question you ask, but, there are better and worse questions. So, for example, if you want to ask me about something that relates to, I don't know, Zig versus Rust, try to ask me specific questions. Because otherwise, if you ask a super generic question about like language wars, the best I can give you is a very generic answer that's not really gonna give you any more insight. So with that caveat, that said, if you have like any kind of Zig programming question, like you want to know how to do things in Zig, I am happy to answer your question. And in that sense, like if you're asking how to do something, then in that specific subcategory of questions, I do think there are no dumb questions. So feel free. I'm reading the Zig doc. It does not seem to finish. Well, the language reference is one page. Yes, it's one pretty big page. So my recommendation is, it's not a bad idea to read it. Do check it out. Don't stress it too much. Like there's going to be some things where maybe, there's going to be like the full table of all the built-in operators or all the built-in functions. You might want to take a scroll through it so that you get an idea of what's there. But you probably shouldn't stress it much. Like if you don't remember every single built-in in the compiler, that like in the language, that's fine. The point is, it's a reference, so you should reference it whenever you need it. So you should take a first pass, give it a first pass, so that you know where things are generally, and then keep it around when you do things and pull it up and read things on demand. So in other words, you should like page in a sense, the reference. You just page it in, and then anyway, sorry, I was trying to make a virtual memory joke. I suck at this. I'm really interested in Zig, but the lowest language I have used is Go. I'm really struggling with wrapping my head around not having strings and instead having to use U8 const. Any recommendation for help with this? I feel like I'm making it too complicated, but I'm really struggling with it for some reason. Yes, I can help you with some things. So, you're not the only person who has only higher level programming experience with like Go. I do think that Go is generally perceived as being lower level than maybe other languages in its same vicinity. That said, personally, you know what? With the insight that I've gained by working with languages for a while now, and I haven't seen more of the spectrum of low-level to high-level languages, Go in reality is at the same exact abstraction level where Java and C# are. The difference is that in Go, you do less dumb shit than the other two languages. Like in C# and Java, people go bonkers with certain things. With Go, you tend to have more, mechanical sympathy, but it's still a fairly high-level programming language. Your specific problems with strings, I think, can stem from two problems, two things. One is you need to be able to use Zig correctly. You need to learn pointers and slices and what they do, what they are, how they relate to one another, what is a sentinel, what is like you should be able to immediately distinguish the notation for a slice versus a pointer to many, that kind of stuff. So you need to learn the notation, and I'll give you now some links that can help you with that. And you need to understand how those things relate to what's going on behind the scenes. So for example, here's one problem that can happen. If you make a function that accepts a slice of U8s, like a slice of bytes, and then you try to pass it a string literal. So you have this function, right? You know what? Maybe I should make a new buffer. So you have this function that accepts U8 and does whatever with it. And then you call foo with hello world. Well, this is not going to work. Why? Because a string literal, it's not a U8. It's not a slice of U8. It's a const slice of U8, because this string, like string literals in programming languages, get interned, so they get copied, like they get deduplicated and copied in a section of your program memory that is immutable. And the reason why it's immutable is because they get deduplicated. So like if you have hello world, or maybe a name for something referenced in 2 or more different locations in your program, they will all point to the same memory, but then that means that obviously you can't change one, because then you're also going to change the others. So it's like a trade-off. But in general, string interning is a very good idea. So it's totally worth it as a trade-off. So what's the problem then? Then you have this, and the thing is going to complain, and it's going to tell you, wait, it's a const slice, and you want a non-const slice. So maybe you can figure this out. So like the fix for this is const, but it can get also a little bit more complicated, because in reality, I said that this is a const slice. Now that's not exactly true. What this is something more specific. It's a pointer to an array of, I don't remember how long is hello world. What is it? 11 characters. God damn it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait. Okay, let's say that it's 11 characters. I don't remember if it's correct or not, but you get the idea. So it's a pointer to an array of 11 bytes. But an array of 11 bytes, sorry, and I should say it's a const pointer to an array of 11 bytes. But this type can coerce, so it can be translated automatically, converted automatically by the compiler to this. And this transformation can happen without you using notation. But as I said, this can happen, but this cannot happen. You cannot do const 11 U8 to U8, because this is mutable and this is not mutable. I told you why this is the case for string literals. But in any case, the point is, you exist in this space. You have to be aware of these coercion rules, of the meanings of these things. Like a const pointer, like constness is an important concept in a low-level programming language. You need to be aware of it. So this is the kind of problems that usually bite newcomers. The second layer of problems that you might get with strings comes with encodings, because a string in Go is a sequence of runes, and so it tends to kind of help you dealing with like emojis and UTF-8 and Unicode more in general, that kind of stuff. Zig doesn't do that for you. You can take a slice of bytes and you can decode it as UTF-8, and if you decode it as UTF-8, it will yield to you a series of code points, which are like U21. I think it's 21 bits that are necessary to represent Unicode code points. So you have that. And that's actually the same using the appropriate functions. I think the standard library has bytes to UTF-8 code points. UTF-8 bytes to Unicode code points, and you get this. This is basically like a Go rune. But then you could have like UTF-16, UTF-32, depending on the ecosystem that you're in. And I think the standard library has UTF-16 functions because of fucking Windows, but I don't think it has UTF-32 stuff. I might be wrong. But point being, you have to worry about this. Previously, you didn't have to. But in reality, Go wasn't really going the full length. It wasn't doing everything for you because a rune, like a Unicode code point, isn't like a character. You have emojis that are actually collections of code points. Like an astronaut is person, zero width joiner, rocket. It's like actually, well, 2 emojis and a Unicode and a special Unicode character, and they all together form the astronaut, and that's what's called a grapheme cluster. So you also need to be aware of grapheme clusters if you actually, depending on how sophisticated is your text processing. For example, Bork here, my Twitch chat client, does this indentation of text manually. I have an algorithm that I wrote myself that looks at how much space is available on a row and decides whether the next word should go there or on a new line, etc., etc. And to do that math correctly, it also needs to understand how wide is going to be any single thing. So it needs to know if like person, zero width joiner, rocket should occupy like 2 cells or only 1 or whatever the heck. And so you don't get that from Go either. If you were to try and program the same application in Go, you would have to fiddle with this stuff as well. So long story short, when it comes to encoding, in higher level programming languages, usually you tend to not be aware of all the complexity and actual nuance that is behind Unicode and its encodings, UTF-8, UTF-16, UTF-32. Some of it, it's nice, like it's nice that the language takes care of that for you, namely what Go does with strings, giving you runes, but it's not a full solution. You will produce messed up shit no matter what, because you can't fully escape from the complexity. Like at certain levels, you need to understand what the platform that you're operating on does. The platform in this case being like UTF-8, Unicode and the way it works. So Zig doesn't give you that, but it's not like, how can I say, it's kind of like taking off the, what do you call them? The training wheels. Like now you're without training wheels, but like the whole point was that you needed to learn how to ride a bike anyway. So that's another thing that can be a little bit problematic. Don't how can I say, don't stress it. Take it one step at a time. Ask questions to people. For example, as I was implementing my HTML tokenizer and parser and everything else, we were having discussions about whether do you need to decode UTF-8 to write a correct HTML parser, and my answer is no, you don't need to do that. But the reason why this is the case requires understanding even how UTF-8 is encoded. So there's a depth of things that you'll never think about in higher level programming languages, and like it's there, and you can play around with it, but it requires understanding it, and like it's necessary. It's not accidental complexity. It's like it's part of life. It's totally part of life. That said, okay, let me give you some pointers, some resources. So Zig News has a couple blog posts that I think are interesting. Let's see, cheat sheet. This is one, but this is not the one I had in mind. There's another one. Let's see, pointer. This one is another one that I want to link to you after. Oh, there we go. Beginner's notes from David Wanderson. So this one will tell you a bit about the various notations for pointers. By the way, this is also information that you will find in the language reference. It's just that this blog post does, in my opinion, a pretty good job at like giving you more context. Like I think the Zig reference kind of tends to assume that you already know what's up and you only have questions about the notation, while this one goes a little bit further. This is one. And the other one is from me, and it's about string literals. It basically spends more words on explaining what I already explained by voice. There you go. As for encodings and like UTF-8 stuff, let me recommend Zigster, which is on Codeberg now. Yeah. So Zigster and Zigleaf are basically the go-to libraries for dealing with Unicode in a serious way. So if you use these libraries, especially if you use Zigster, you will get a string data type that you can use with all the bells and whistles that like relate to Unicode stuff, like properly and iterating grapheme clusters. For example, I'm guessing that this accented E is not just like one code point, but it's an E plus probably a joiner plus an accent code point, which then should basically means glue this accent onto this letter. And that's like something that you would fuck up guaranteed if you just use like what Go gives you out of the box. Obviously, Go will have also libraries for Unicode. Does ZigSTD have no UTF-8? It does. But don't hear Mordillo. Here's the important thing to understand. UTF-8 is not Unicode. UTF-8 is an encoding. UTF-8 says, listen, this combination of bits, these following combinations of bits map to this number, to this like entry in a dictionary. ASCII is both a dictionary and an encoding. I'm using dictionary in like a somewhat lax way. I don't think they define these things as dictionaries. So allow me to use the term, but like don't assume that the term is like official nomenclature. So with ASCII, you know that like, what is it? 96 is like lowercase a or something. I forget the exact numbers, but like you know that the byte sequence, you take one byte and you set it to 96, and that's going to correspond to letter A. UTF-8 says that whatever a bunch of like a specific combination of bytes should be interpreted as value 96. What 96 is defined by Unicode. So Zig does have facilities that can take you from a specific series of bytes to the slot number in the Unicode dictionary. But the properties of that slot number in the Unicode dictionary, they are not in the Zig standard library. They are in this library here because it's like a few tens of megabytes even of XML files that define which slot, like which character is like alpha, which character is a number, which character is a breakable white space, which character is punctuation, right? All these properties, these are Unicode. These are not UTF-8. So, and the difference between UTF-8, UTF-16, and UTF-32 is which byte combinations correspond to which slot number in the Unicode dictionary. So Unicode is going to be the same. It's the same for UTF-8, it's the same for UTF-16, and it's the same for UTF-32. But, in UTF-8, slot number 1000, which might correspond to, I don't know, like a weird accented letter, will be, like 2 bytes, because UTF-8 is variable length. For UTF-16, it's going to be maybe 4 bytes, and for UTF-32, maybe also it's going to be 4 bytes. And what specific bytes are going to be between UTF-16 and UTF-32 could be even different. Probably are different, actually. I don't think they correspond pretty much ever between UTF-16 and UTF-32. So Zig has UTF-8, yes. I think it has some UTF-16. I don't know if it has any UTF-32, but then once you get the slot number in Unicode, then if you want to know more about it, you need a third-party library. Because also the Unicode spec is like always moving. They release updates. Like whenever they make new fucking emojis, that's an update in the Unicode standard. Don't get me wrong, Bit is great and all, relatively small memory footprint, but we already maximize our usage on instances and clusters, so it was another benefit to further reduce and a little extra breathing room. Okay, cool. Thank you. Yeah, no problem. Let's see that gist from CryptoCode. Or should I say gist? That gist. Oh, that's the one with the boxes. Oh yeah, you know what? This one is also pretty cool. I keep forgetting that it exists. because it's not like posted on an actual blog post. But yeah, this one is cool. So yeah, I would also, echo what Critical Code said. Check this out; it's pretty cool. This one also helps with understanding pointers. Okay, so I hope I answered Slow Kill. I hope I answered the text question in a satisfactory way. Better terminology, dictionary, table, slot, code point. Yeah. Well, I didn't want to use code point because it's already a term that people throw around, and since people get used to what a code point is, they don't spend effort thinking what it is in a more concrete term. So I wanted to use new terms on purpose. But yeah, dictionary to table is probably not a bad idea. Yeah. Unicode is a table, and each entry in that table corresponds to a symbol. UTF-8, UTF-16, and UTF-32 use different encodings to map a sequence of bytes to an entry in that table, but then what the entry in that table means, it's defined somewhere else. And it's a reasonable idea for languages to not bundle that information in their standard library because it's a moving spec. So it's annoying. Again, new emojis come out and oh no, new emojis came out, but now I can't leverage the hottest new emojis that just came out. I can't use my pink poop emoji because the standard library, I need to wait for the next release, the next version of the language. That's not a great idea. And then you also have to download, I don't know, you can compress the data, the XML files. I think that, again, I don't remember how big they are, but they are freaking chunky. But obviously you need to bundle them all in that way in your language all the time, or in your executables. But and so you can compress this information. But I still believe it's not nothing. It is something. This depends on ZG and cow list. Okay. I wonder what ZG is. Also, cow list is probably interesting. Let's see. ZG, cow list. ZG provides Unicode text processing for Zig projects. ZG. Oh, that's Zigleaf. Oh, god damn it. That's Zigleaf. He renamed it, I guess. He's also still working on this stuff. I remember that Mitchell made some changes. Mitchell was using Zigleaf in the beginning and then wanted to get better performance out of certain stuff or reduce memory footprint or something, or both probably. And some of these changes then were basically backported into Zigleaf after the fact. Oh yeah, there we go. ZG. Relation to Zigleaf. Okay, so ZG is a total rewrite of some of the components of Zigleaf. Okay, so you know what I said is Zigleaf is the go-to thing. I guess now it's ZG. But in any case, both are projects from the same person. So Dude the Builder is doing a good job at working on this stuff. So yeah, cool. So current name, blah 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 blah. What's the build error that I got? Let's see. Tokenizer one span is not a function. You're right. It's .span, .slice. Okay. I should rename span to name. You know what? Maybe we should really rename span to name. Let's go do that. Where's span? Span becomes name. Oh god. Yeah, now we're gonna need to change. Oh, you know what? Here's what we can do. Rename. Okay, hopefully we fixed it everywhere that matters. Not sure if we actually did, but okay. So this becomes .name. Yeah, this is much more explicit. Cool. So let's see. No field name span instruct blah blah blah. AST 169. Yeah, this is now name. Well, this is a different file, so that's why references here didn't get updated. 187. Oh yeah. Okay. So we did that, but I think there's more. Yeah, there are more errors. Okay. Assign all possibilities. We're not handling element self-closing. In the AST in the parser, we are missing element self-closing. Wait, no, is that a render? What is it? Line 12. What? Okay, wait a second. Oh, this is the node. Where is the fine? Okay, 38. That's the actual line. 38 here. We don't have elements of closing. Yeah, elements of closing is like only after, always after. It goes here. No field name LHS instruct ast.node. Mm-mm-mm-mm. 44. Right. So, what are we looking at? All right. Previously, I had to look at this because it was not self-closing was not like an element type, so we don't have to do this anymore. Now, what I look at is if it has a close thing or not. So, if close to start is 0, then it means that we didn't find a closing tag. So we want to go in. If we did set this, it means that we're going out. Okay. Next things. Line 50. Oh, here, same thing. No field name span. 305 tokenizer 1. Oh man. Okay. Now if you name LHS 289. So we're looking at a doc type and we're asking, do we print the doc type with a name or not? Oof, actually this requires us to retokenize, doesn't it? Oh, that is annoying. I think I need to make a function for this at this point. Like this needs to become a function. Something like retokenize name or something. Or get name, maybe. Get main token, get name. Let's call it get name. So get name takes I guess we can do it on a span. No, I'll put it here. So we accept a span, well, tag, I guess, is a span. And in here we do what we were doing earlier, which is to do this. Create a temporary tokenizer. Slice the tag. And then do tag. Oh, but these expect the thing to be a star tag necessarily. Fuck. Fuck. Okay, I take this back. We go for the copy paste approach. Instead of factoring this out in a function, we copy paste. It's like 3 lines, very similar, fair, but we're not gonna have to do this, I think, in many other cases. It's mostly just the doc type. So where did I need to do this stuff? In the renderer, right? Yeah, in the renderer. We wanted to decide whether to put something in there or not. So first we need to retokenize maybe name. Then we do doc type dot name row. And then we need to say, yeah, maybe we have the name row. And if we do, we decide blah, blah, blah. Okay. So this is also fixed. Let's see. No LHS. Oh, God. Right. This printing thing needs to be changed completely. Because... oh, don't tell me. Here we have the same problem. Yeah, here we have the same problem. Fuck. For both cases. Oh, that's annoying. So we tokenize close, and then we expect to find a end tag. Change the name, and then we slice. This is what we print. Okay. Let's see. Unexpected optional type found span. Oh yeah, right. This is not optional anymore. This is always present. It's just that sometimes it's initialized to 0. So how do we do this? How do we do this? Do you know how HTML parser works exactly, or do you go through some book about HTML parsing and you implement that in Zig? It's a bit of both. I do have some experience writing parsers and tokenizers. I wrote all this stuff for a JSON replacement language. This one. I made my own JSON replacement. I still have some like design iterations to do there. But in any case, I gained some experience doing this. Honestly, if you're interested in languages, tokenizers, and parsers, and that kind of stuff, I would even recommend you know how people make their own toy languages? I mean, fair. If that's what you like doing, go do it. But I find that it's really nice starting with something that is simpler than a programming language. And the language for a data format, it's a great way to start, because what you can do is, like, since the thing is much simpler, you can push further with the tooling. So for example, I wrote this thing. I wrote a tokenizer, I wrote a parser, I wrote a 3-seater grammar so that I can have syntax highlighting. Like the syntax highlighting that you see here, that's 3-seater. I wrote a schema language for it also to define schemas, and then I wrote a CLI tool to do formatting, querying. Well, querying is still a to do, but I have plans for it. Syntax, like schema checking, conversion, and DLSP. Like DLSP is the most complete. Well, formatter and DLSP are the most two complete things in this tool, and this has been a great experience. So here's what I would suggest. That said, for HTML specifically, there's a standard. Like you can find these HTML spec, and the HTML spec will tell you how to write a parser for it. It will tell you what the state machine is supposed to do. So it's not like going to give you source code, but it's going to tell you, look, the tokenizer starts in the data state, and then it consumes a character. If the character is one of these characters, like if the character you find is a greater than, sorry, it's a lower than, like a left side diamond bracket, then move to the tag open state. Blah, 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 blah. Be careful, because the HTML people were high on mushrooms or something, LSD, when they wrote these docs. They have really weird ideas about what a tokenizer is. That said, it's the official spec. So you follow the instructions here and you are going to be spec compliant. So it's a bit of everything. The HTML spec, like, you just search for HTML5 spec and you will find the official documentation. Yep. Okay. So don't they just assume a tokenizer is a state machine? Lemna, you might need to write some more for me to be able to answer your question in a meaningful way. Don't they just assume a tokenizer is a state machine? Do they? They do say that the tokenizer is a state machine, yes. But I think that as a statement is not particularly controversial. Tokenizers, generally speaking, are state machines. As they produce one token, they tend to have internal state, and they tend to mutate their internal state as they consume more characters. Most tokenizers will not require state that carries over between one invocation and the next, one token and the next. So the tokenizer is going to be stateless between one token and the next. So you can create a new instance, for example, of the tokenizer and feed it some more characters, and then it will produce a new token, and it's fine. Whatever token was produced before isn't relevant. You will always get the same behavior. This one, no, though. The way the HTML people want you to write the tokenizer is different. That tokenizer will have state that carries across tokenizations, and it will behave in a super weird way compared to what tokenizers are normally. It's a choice, obviously. It's a weird fucking choice. It makes me, it made me ask questions about the sanity, even the competence of the people who wrote that thing. That said, we shouldn't be dogmatic. Even if they tell you to write a tokenizer in a way that is not how tokenizers are usually implemented, that probably they had reasons to do it that way. So, like, the idea is open your mind, try it out what they say, and come to your own conclusions, I guess. I'm coming to my own conclusions, that's for sure. So, tokenize end tag name slice. So this is fine. What's the next problem? Right, it's the current.close thing. Right, close is always present. How do we recognize when a close is fine or not? If current.close.start is different than 0, then we do this. And now we hit a to do. Because we got a parse error, EOF in tag, and that made us hit a to do. Oh, that's nice, because I'm testing the bad example. So I'm basically running only one test. The final test where, well, not the final, like the where is it? This test where there's like a specific error that needs to be handled. We're not handling it. Where are we not handling it? EOF in tag. I think this is in the renderer, I think. 260. I think that's the renderer. And I am wrong. 260 is not the renderer, apparently. Here. So then I parse error. Direction is after. Oh. Oh. Oh, that's bad. That is bad. Wait a second. Wait a second. Start tag. Where's my start tag? Oh yeah, I'm not setting and. Sorry, I'm not setting close. Yeah, there we go. Now, still EOF in tag. But this is somewhere else, right? Access of union field start tag while field parse error is active. Oh, 315. So let me think. What happened here is I'm tokenizing this thing and that produces an error? Huh. Have there been discussions on adding Zig to the Linux kernel? I was wondering the other day hearing Linus talk about Rust. So, first of all, Zig is still not as far ahead as Rust. It's a much younger language and it's not 1.0 yet. It's unstable. It doesn't have a spec. These are all things that make it problematic to add to a project like the Linux kernel. While the language itself is probably a decent fit for what the kernel does, one could even argue maybe even a better fit than Rust in some ways. The problem is it's unstable. So until Zig becomes more mature and stable, you can't really add it to the kernel, or rather you can do it, I guess, but then you will have a bunch of downsides, big downsides that, you know, are going to impact big companies, and like it will create labor, a bunch of labor. It's not just like, it's not like in my own tiny library that me and two other people are using. It's something more complicated. So that's like the big problem. Like that's the deal breaker right now. As for the future, I don't know, maybe not. Honestly, the point is that from our perspective, from the Z project, the ZSF perspective, it's like it's up to the Linux kernel to decide what they want to do. Like, you should not expect us to do any lobbying to get Zig into the kernel. I don't know to what degree people involved with Rust cared, but I believe there was some more active interest, some more active push to get Rust into the kernel for whatever reason, so that, you know, they could get better memory safety, security concerns, whatever reason they had to push for Rust into the kernel. I believe there was some more active involvement. I don't think we will be as involved. So ultimately, you know, it's like, okay, is anybody who's already a big Linux contributor who wants to get Zig into the kernel, fine. Or let's assume that Zig is mature enough, right, where that makes sense to do. Fine. At that point, when that happens, they can open an issue on our repo, and we are certainly going to help them do that. So, like, if there's anything that Zig needs to support, it doesn't support yet, or stuff like this, we will totally look into it and prioritize it for sure. We'll try to unblock them, but ultimately it's something that, you know, it's an effort. It's something that has to, it's something that needs to be born from the kernel people, not from us. So that's kind of our stance on that. Let me think if there's anything else to say on this topic. So yeah, let me just give you like an idea of like where Zig is with respect to Rust. Okay, this is like how can I say, I'm not going to show you, you know, the most authoritative resource that is going to give you clear cut information about the complete state of things of Zig versus Rust. I'm going to show you a vanity metric actually, but it does have some meaning, so take it with a grain of salt, but it does have some meaning. So check this out. Star history. Star history of Rust. Please don't ask me for a key. Okay, good. Thank you. So check this out. This is Zig versus Rust. So here's what you can see. One, Zig is much smaller than Rust. Rust is what? 4 times what we are? Like, well, maybe not 4 times, but like just to simplify the number, let's say that we are at 20K. We're higher than that, but let's say they were at 20K. They're past 80K. So yeah, they're like more or less 4 times as big as we are in terms of stars. That doesn't mean that the ecosystem is going to be exactly 4 times as big. Although, you know, probably it's a reasonable, you know, back of the envelope estimate. Loris is a madman. React with emojis if you agree. Lucas. Yeah. So this is where we are. Another thing that you can see is that Zig is like a much younger project. Like Zig published around 2016. Rust was already out at this point. Here's what happens if you align the timelines. This is where things become interesting. If you align the timelines, then you can see how we fare compared to Rust when they were our age, if that makes sense. So if you look at it, we're doing equally well. If you want to be nitpicky about it, we surpassed Rust back when they had our age. So if things continue with this same, you know, trajectory, we're gonna be fine. And in a few years, we're gonna be more or less where they are now. And then, sure, just like Rust can be in the kernel today, Zig will be able to be in the kernel again if they want to do that. Honestly, they're like, do not expect me to go knock on their door. Like they're not gonna get like a cold email from the Zig Software Foundation. Hey, you want to get Zig into the kernel? It's like, do they want it? They like, if somebody there wants it, fine. Otherwise, whatever. But it will be realistic at that point for sure. But we're not quite there yet. So you can be optimistic about it, I think, but not exactly. And to be clear, it is not guaranteed that our line will continue exactly with the same, in the same way that their line continued. So like, you can maybe conserve, you know what, again, you can be optimistic, but you don't know that for sure. So this is kind of where we're at right now. Rust about the GitHub stars. Lucas, you can't say that. You know why? Because GitHub stars, like, what is a GitHub star? Think about it. Think deeply about it. What is a GitHub star? Where's the source code? A GitHub star, it's pretty much an emoji reaction. It's an NFT. It's an emoji reaction. And you know how it is with emoji reactions. They tell the full story. So this is the actual ground truth. Okay, for the people who don't know the fuck I'm talking about, we're still memeing over this comment here. This is like a controversial, I don't know, somewhat controversial, vaguely controversial issue that was open in the Svelte repository about HTML parsing, and then this guy goes nuclear, goes bonkers, and says, as often is the case with this sort of changes, a vocal minority opposes it, but the emoji reactions tell the true story. So it's like, by the way, I don't care about the actual issue in question. I don't care. It's just like, I find this sentence hilarious. Like, this is a gem. Like, it's like, I think he wrote this like with a straight face, but think about it. Can you say with a straight face, the emoji reactions tell the true story? So anyway, we've been memeing about this thing for like a full day now. Anyway, yeah. Man, can I react to this? Why am I not allowed to react to this comment? Actually, let's check out my Twitter stocks. I made some Twitter investment. Let's see how my stocks are doing. So I was memeing. History might be written by the victor, but the emoji reactions tell the true story. So, oh god, why does it take so long for new things to pop up in Twitter? Why is it like this? Wasn't Musk supposed to make everything better? The likes tell the true story. Yep. And Elon wrote the truth. Oh my god. Wait. But taking likes private, what does that do to the truth? Let me think about it for a moment. I don't know. I'm not sure. But this is gonna influence what is true or not, if you think about it. Yeah, okay, so I'm sorry, I've been spamming just stream or online notifications on Twitter for a while now. People probably got bored to from my stuff. That's fine, whatever, fuck Twitter. Anyway, where are we at now? So the problem is that we're looking for a start tag thing, but we're getting a parse error. Oh, okay, so now actually, you know what, this is interesting. So we're getting, what is it? We're looking for a start tag. So this is line 315. So we're rendering. We're trying to render the start tag, but we get a parse error. Okay, the problem here, I think, is that what we think we are getting in here probably is not what we think it is. So let's check this out. std debug.print slice. Well, you know what? Retokenize. Let's see what it is that we're retokenizing. And it's probably not gonna be what we think it is. Yeah. we're missing a piece. We're missing a piece. Whose fault is this? Whose goddamn fault is this? So start tag, right bracket. We do write it down. And we do write it down correctly, but that means that we don't tokenize it correctly. So tag open, well, where is it? I guess we can see where it is that we generate a start tag right bracket token. Where is it? So we're doing a -1 there. Oh, this is the only place where we generate 1, and we're doing -1. And I think that that's what we should not do, the -1. Yeah, and now we retokenize the correct range. Retokenize the correct range again, and then panic. Start index 14 is larger than end index 0. That is good. So end index 0, I think, tends to mean that we did not set the end correctly there. So AST 314. Wait, is that an info thing? Yeah. This happens in tokenizer 23. Yeah, but wait, AST 314 asks for the slice. Oh, I'm in tokenizer, that's one. Okay. 314, 314, 314. So we are slicing this bad boy. The slicing doesn't work. That means that we have an element that's missing something. Let me think. So we do HTML, we do body, and then we die. What were we doing here in any case? Wait, which test is this? Oh, it's still bad. So HTML body, and then there's P. Oh, that's the problem. The problem is that, well, we actually did fail halfway through dealing with P. And so that's why we don't actually have information. We don't have good information about P. And that's a problem. It is indeed a problem. If you had one thing that you would change about Zig, what would it be? Interesting question. One thing that I would change about Zig. So it's a tough question because there are obviously some things that would be nice that Zig had that doesn't have today. But I don't know if that would count as changing Zig. Like Zig doesn't have a book, for example, that has been published. So it's saying that it would be nice to have a book, you know, yeah, it would be nice, but it's not exactly a change. It's just something that hasn't happened yet. On the other hand, you have like language features. And man, those tend to have so many freaking tiny implications where I could say that maybe I would want something, but the implications of that thing could be problematic. So maybe it turns out that it's a trade-off that I wouldn't want to have. I'm just not aware that that's the actual trade-off that I'm getting myself in. So that said, right now Zig doesn't have async await. As a feature, I think it's extremely interesting. It's not non-controversial. So it is a little bit controversial because you could argue that maybe as a systems level programming language, Zig maybe shouldn't have async await. Although it is a nuanced discussion because sometimes people say that Zig shouldn't have async await because they think it's a high level programming language feature, while it's fucking not. Async await is as low, when it comes to like coroutines, is as low level as you can get pretty much. Specific languages attach behavior behind the usage of async and await keywords in a way that Zig didn't do. Zig used to have async await, but it doesn't have it anymore in the current implementation of the compiler. So the behavior of async await in Zig is not a one-to-one map with what happens with other languages. So yes, the way, for example, async await works in JavaScript would be like the whole thing would be a bad fit in Zig, but that's not what it is. That's not how it works. So people sometimes say that Zig shouldn't have async await because it's a high-level programming language thing, and I disagree. High-level programming languages should have structured concurrency, like coroutines. Like CSP, actors, that kind of stuff. And async await is stupidly low level at that level of abstraction. We just don't realize it because that's what we've been given with pretty much the ecosystems that spearheaded that type of concurrency. So namely like Node.js, that's the main example that comes to my mind. That said, async await is a little bit controversial because it makes the generated machine code weird in a way that you could even argue, I don't know, maybe it shouldn't be exactly like this. It's more like the machine code that you generate is funkier than maybe what you should be prioritizing as a language. That said, there are many ways in which Zig is able to pull off async await in a unique way. For example, async await tends to be very viral as a thing. Like you have, for example, in Python, you have the blocking version of a library and then the async version of a library, and that's like duplicated effort. Like you want to use a database, you will have the blocking client and the async client, and those are two different clients, and both need to be developed, and they don't interoperate between one another at all. In Zig, you don't have this. In Zig, async await is not viral at all when it comes to syntax. Like you will not have the necessity of duplicating effort. From a computational model, it is still viral because of how async await has to work, but it's a completely different deal than what you're used to in other languages. So, long story short, I think that async await is an absolutely interesting thing to explore. It comes with some drawbacks, but it has never, and it really has never attempted this way in a language before Zig. I don't think it has ever at all. And I think it has the potential of being something fucking amazing. So if I had to change something, I would say it would be nice if Zig had async await. That said, there are reasons why async await has not been re-implemented yet, sorry. And that has to do with the Zig memory model, because there are some bad implications behind certain features that async await requires that have bad interactions with one another. There was a talk that was given a while ago about these features and the problems that they bring. And until that situation is solved, async await cannot be introduced. Or rather, well, I guess you can introduce it, but then maybe depending on what you decide to do with those underlying memory model features, then you will have maybe to strip it out anyway, because you decided to get rid of the one thing that async await required you to have in order to work correctly. So, yeah, it is complicated. In any case, not really Zig related, but do you use a tiling window manager for macOS? I have, what's it called? I have this thing installed, Square. I think it's called Square. No, Rectangle. Sorry, it's called Rectangle. I have Rectangle installed. I don't use it much, honestly. Mostly I'm managing these windows manually, but I'm doing like lazy web dev, so I'm not really taking this super seriously. When I want to do serious development, I switch to my NixOS machine. When I do more serious systems programming, I switch to NixOS. This is i3, and so this does the tiling for me. So so this is what I have, but like I don't take that super seriously. I know that the latest macOS, the one that is about to come out, will have more built-in tiling features. I don't know. Make it OP. Oh god, no. I'd pump out the type system just a bit, but not full-blown FP boner. Okay, here's another maybe more wishful thinking type of thing. I wish, which again means that maybe what I wish makes no fucking sense once you get down to it, but I wish that CompTime had an easy way of printing out as source code the types that get generated through metaprogramming. So the ability to say, okay, this is a struct that will be generated through metaprogramming, but I can also print it out and take a look at it as source code. That would be nice. Currently, if you do a bunch of CompTime metaprogramming, you don't really get a chance of observing the output of your metaprogramming. So you can create programmatically a struct definition, but then you have to derive what a specific instance will look like based on your reasoning. You will not be able to print it out and look at it. Something like C compilers -E. Is that like the macro expansion thing, I guess, something like this, except that, well, in the case of Zig, it's more complicated, right? Because it's not macro that's going on. It's like, I don't know even exactly what are you doing when you do metaprogramming of that kind. Are you even generating ZAR? Maybe you're not even generating that. So again, as I said, it might be more complicated than what I think it is, but it would be nice to have. That's my wishful thinking thing. Will WASM continue to be a tier 1 target without LLVM? WASM will always continue to be a tier 1 target, yes. Without LLVM, the way you phrased it seems to imply that we're gonna like yank LLVM and then just, you know, YOLO it without LLVM, but that's never gonna happen. Zig will at some point get rid of LLVM as a compiler as a build dependency of Zig. So you will be able to build Zig without requiring to have built LLVM before that. But the idea is that the Zig compiler, what it will do is produce output. When you want to have like a release build, you will output LLVM IR, and then you will be able to get LLVM through the Zig build system, just like you can get via the Zig build system other dependencies, and then use that LLVM to build the final executable. So Zig will always be able to produce optimized releases like it's doing now and leverage LLVM for that kind of stuff, including WebAssembly. But the idea is that it's not going to be part of the compiler itself. It's something that you will leverage to the build system. So ultimately, as a user, like it won't really change much for you. You're still gonna be able to satisfy all the use cases that you're able to satisfy today. It's just gonna work out in a different way. And if you're gonna be somebody who develops Zig, then you're gonna have a much better time, because if you want to compile Zig, then you will not need to compile LLVM anymore. Last thing related to this is that we will at some point start the work on a optimizing backend that is not gonna be based on LLVM. So we will have our own optimizing backend. Obviously, it's not going to be as good as LLVM in the beginning, and probably it's not going to be nowhere near as good as LLVM for a long time, but you will still have the options of doing whatever you want. Do you want to use the built-in optimizing backend and get something that's going to be, you know, release better than debug, but not as good as LLVM? And if that's good enough for you, then you can use that, and ideally, I guess it's going to be faster. So you can imagine that as a Go style type of thing, right? Go builds fast, but it's not as optimized as LLVM, nowhere near. So that's going to be kind of like this. And then over time, maybe it will become, you know, good enough that, you know, even if we assume that it will never be as good as LLVM, which is, you know, it obviously requires a ton of effort, but it is not guaranteed that that's never going to happen. But even if we assume that, so we are trying to be conservative with our optimism, even then, it might get to a point where it's still going to be good enough for whatever you're doing. And so maybe if you're not doing like embedded, where you need, you know, release small as possible, then you're going to be good with our optimizing backend. Lastly, with this point, you know what, it might even be though at some point that the people contributing to LLVM will get tired to mess around with C++. They will get tired to having 45-minute long build times, and maybe they will start getting interested in experimenting with optimizations in a compiler toolchain that builds in the blink of an eye. So nothing is guaranteed. It is not trivial to you know, compete against LLVM. Absolutely not. But it's not all that impossible either. So we'll see. And in any case, as I said, the plan is to never give up anything and only open the door to improvements, which hopefully will happen, not guaranteed, but along the way you don't lose anything, pretty much. So just get LLVM through the build system and get your release builds that way until the new built-in backend is going to be good enough for that. Let's see. Christoph IT, where do you work at? I work at the Zig Software Foundation. Why are you tagging everybody with this question, man? I work at this. I am VP of Community at the Zig Software Foundation. Working at the Zig Software Foundation is my full-time job. Coming from Go, I'm a bit confused by Zig's package dependency management. Any up-to-date resources you can recommend? Oh, yeah, it's a little bit more complicated. So, you know what? I'll give you the quick rundown of what you're facing coming from Go. Go has a package management story that it's like simplified to an extreme degree. You pull in new dependencies by, well, pasting the URL in your source file pretty much. Your tooling, like what you pull in from our dependencies is normally just a module. Do you guys call them modules? No, you call them packages, right? You get a package from your dependency. So like a Go package, and that's it. With Zig is more complicated, and it has to be more complicated because in Zig, in the Zig world, the items that you're dealing with are going to be static libraries, dynamic libraries, tools that you might want to build that then do some pre-processing of something. Some of these you could argue would be nice if it wasn't the case, but it is the case. If you want to build a C project, you need to be able to invoke random executables to do that. And so the Zig build system has to be more complicated. And when you pull in a dependency, then pulling in a dependency is not going to be immediately trivial like in Go, because what the dependency that you're pulling in could be trying to expose to you, or rather, you might be interested in getting from that dependency an executable that you want to invoke as part of your build process, or maybe a static library that you want to link against, or maybe a dynamic library that you want to copy paste in the final output directory, or a Zig module. So this is like a Zig package. What we used to call Zig packages in the past, and today is a Zig module. So it's like a bundle of Zig source code with like a root file that you import, and that in turn imports all the other things that the module wants to expose to you. And actually, a Zig package can contain multiple of these things. So a Zig package, like a Zig dependency, can contain multiple static libraries, multiple dynamic libraries with their C header files, multiple Zig modules, multiple executables that you might want to pull in because you want to use them in the build process, or for whatever reason. Maybe the executable is also something that you want to output in the final installation directory or something. I don't know. So like, point being, the problem space is much bigger compared to what Go does, because this is how this stuff works. This is how computers work more in general in terms of like that abstraction layer. So with that said, here's the resources that I would recommend. I should just search. Some tricks. Oh, I like the in docs. Can I do this? Yeah, okay, I think this is a good entry point. So copy. This is one. The other one is on ziglang.org, learn Zig build system. This guide is pretty good, but it kind of like goes right away into the more advanced stuff. So the one that I linked you first is like for the basic day-to-day, like just give me like a Zig library and let me use it. This one instead is, okay, let's do the funky stuff. Let's like produce an asset and then embed file the asset into the executable and that kind of fancy shit. But as I was saying, we're gonna move this at some point somewhere else, but for now it's there. But in any case, this is like official documentation. Then what else? Yeah, I would say that's pretty much it. So I think this should be enough for you to like get introduced to these concepts. What you described about Zig's build process sounds a bit like Nix could be used for it. Using executables during build, pulling specific libraries for dependencies. Yeah, but, well, they operate. Nix and Zig operate, vaguely speaking, in the same space. They both need to build C stuff. But no, we don't want to use Nix. We want to use our own stuff. This is not something that you can nicely offload to a third-party system. Like, if you offload the build system, your build capability to a third-party system, you have a ton of downsides from that. Like, so this is not to say anything negative about Nix, but like, no, fuck that. We want to have our own build system because that allows you to write the build process using Zig. It allows you to use Zig libraries to orchestrate your build process. You don't need to learn a different language. You don't need to depend on another thing. Like, if you imagine that we were to toss away our build system and just use Nix, well, then every time you get Zig, you also need to get Nix. And if you don't have Nix, then you can't build successfully. Like, no, it's absolutely unfeasible. Sure, there is some redundancy there. Like, Nix and Zig are solving the same problems in their own way, for sure. But it's yeah, it's good for them to be separate. Oh, Nix doesn't work in Windows. That is another problem. Thank you, Doom. That's a good point. So the idea is, when you download Zig, you don't only get a Zig compiler, but you get a C compiler, C++ compiler, and you also get a build system that can build C, C++, and Zig. So for example, right now, you're watching me right now just test my tiny thing, but my static site generator, Zin, the way it works, so let me show you the get started. So here's how it works. You clone a static website written in Zin is a Zig project. So here you clone the official website, you cd into it, and then you build serve. You run Zig build and it works. It works on Windows, it works on Linux, it works on Mac. But then when you look into it, this thing is like complicated. Actually, this is the wrong thing. I should show you the repository for the website. So what happens is that for the website, so wait, dude, okay, so yeah, I'm the owner. Can you, like, Zin SSG, that it's my freaking repository. How can you not find it? Why are you searching it like this? I fucking hate GitHub search. This is so stupid. I was watching a talk from people who developed this thing, coming on stage and saying, oh man, we had to solve this super complicated problem of allowing you to search across all the repositories. And it's like, why are you even supporting search across all repositories? What even is the fucking point, man? And then I'm trying to search my own repository and it's like, oh yeah, there we go. Yeah, it's here. Thank you, Andrew. Yeah, it's here. But it's like, why is it not suggesting it up here? Why is it... It's so stupid. Yeah, man, I'm searching for the repo. Okay. Okay, I found it also here. Anyway, so if you look at the website repository, here's how it works. It has its own build system that basically imports Zin and invokes zin.addWebsite. And what zin add website does is it takes your build graph and adds a bunch of tasks to it. Some of them build the tooling, like, because this is Zin is a bunch of separate tools that all get orchestrated by the build system. So there's like a markdown to HTML converter. There's a layout engine, well, a templating engine, right? So it takes your HTML files, your markdown content that was translated to HTML, glues them together, blah, 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 runs the logic, builds the final output. And there's also other tools. I think right now there aren't that many other tools, but there will be more in the future. So that's kind of the idea. And what's interesting is that this works without needing any other dependency. Your only dependency is the Zig build system, which I think is pretty cool. And then if you want to personalize part of the static site generation process, then you can do that by providing your own executables. This stuff is not really implemented yet. I still need to nail down interfaces, decide how it's going to be structured, everything, etc. But and like give you entry points to personalize things. Haven't done that yet, but it's going to be trivial because it's like multiprocessing. So like as long as your executable conforms to the interface, like accepts the same inputs and puts the output where it's supposed to go, then yeah, it's going to be fine. Whatever you give to it. Look away for just a moment, then look back and there's a rant on GitHub search. Yeah, GitHub search is insane. Okay, you know what? Since we're here, let me show you what I mean, because this is not a joke. I was talking about this stuff with Steven Good accounts a while ago. This would be worth having a dedicated podcast episode. How insane it is. So GitHub search has historically been always bad, I believe. And then a while ago, it got better. At least that's what they want you to believe. You know what? They say it got better, but then you look at the emoji reactions and you learn the truth. So there's this talk. You know what? Let me pump up the volume.
Good afternoon, everyone. How's everybody doing? Good?
Lessons from building GitHub code search. This is an interesting talk. Like, if you watch it, it's interesting. They tell you about the scale of the project. You don't understand what the scale of the project is.
You have a good lunch?
Yeah, let's watch some of it.
Well, thanks for joining me this afternoon. My name is Luke Fransel, and I work at GitHub, and I'm going to talk about some lessons that we learned from building the new GitHub Code Search. So, if you've used GitHub Code Search in the last decade or so, you might have noticed it had a lot of limitations.
Oh, search wasn't all that good.
It was limited in what you could search for.
Oh, no.
You couldn't even search forks.
Holy shit.
My team is the team that was responsible for trying to fix that. And we did it by building a new search engine built from the ground up, designed specifically for searching source code at large scale. We call it Blackbird. And it supports exact substring match, regular expressions, code navigation, like jump to definition.
Nice.
And it's fast.
And it's fast.
Search across billions of files on GitHub and millions of repositories in only a few hundred milliseconds.
Millions of repositories.
But I think it's worth asking, why did it take so long to fix this problem?
No, that is not the question. The actual why you should ask is, why did you implement this in the first place? So, you know what? Sorry,
well,
I'm jumping the shark here.
In fact, I was part of no less
blah, blah, blah.
Of code search. Well, programmers have a lot of questions. Stuff like, where's the get user method defined?
Fine. Why would you ask this question? Okay, here's the problem, okay? This is gonna tell you about all the things that I have to do to really bring this search thing to scale. Fine. But then you look at these questions and like, why are you even able to search for why are you even able to search for foo in every single repository on GitHub? Why? So look at this. Where is the get user method defined? Like, which get user method? Like every get user method ever implemented ever in any code base on GitHub? Why would I look into that? What does this error message mean? Definitely, it's not gonna have the same meaning. Even if the text is the same, it is not going to have the same meaning across all the repositories on fucking GitHub.
What does this error message mean?
Yeah.
And why does this repository have so many YAML files?
Hilarious. Holy shit, man. I haven't laughed so hard since that time that guy turned into a pickle. Anyway, okay, let's continue.
Answer questions like these so that we can help programmers understand code.
Yeah, so he talks about indexing, tokenization, more indexing. Wait, I saw something.
New index from scratch down
I saw something.
When we do we know
original tokenization, blah blah blah.
Somebody worked together to make a code search system a couple of months ago.
Okay,
well,
wait, let's start from the beginning of that slide.
Feedback cycle where it was expensive and it was hard to change, and those things work together to make rolling out any kind of changes really hard. What do I mean when I say it's expensive? Well, when we shut down the last remnants of the old code search system a couple of months ago, it was running on 312 physical servers with over 24,000 cores. Now, this isn't a lot for like a big cloud system these days, but for something that's not the bread and butter of your company, it's expensive. Also, it took months to reindex. So that means that...
Okay, so the new system makes indexing fast. Well, mandatory Rust reference. Good job.
I mean, sort of.
Okay, so they explain how this stuff works.
Those improvements,
delta compression, systemic difference. Like you look at this. Oh my God, you guys had to think about all these. You had to find all these clever solutions to all these problems. Jesus Christ, graphs. Holy shit. That's awesome. 3 symmetric difference, obviously. Cardinality estimation, probabilistic data structures, geometric filter, geometric sort filter. Cool, like all this cool shit. Like as a dev, you love, right? Messing around with all this stuff. And then in the end, where is it? There's another thing that I really
so when we started this project,
enjoyed hearing about.
In indexing time, rebuilding an index term takes to the amount of duplicate. If you remember this chart from about the old code search, we had 312 servers. We only have a backup for our index, but we have a
Wait, cluster. Isn't that way more memory? What happened here? So they went from 20 terabyte to 65 terabytes. I mean, good job with everything else. Everything else went down a lot. Good job, but the memory did increase a bunch.
This is 3 redundant clusters.
3 redundant clusters. And 2 crash servers.
Redundancy lets us not only have a backup for our index, but we have a cluster that's dedicated entirely to experimentation. So
okay, cool. Like giving some kind of like CI to devs is good. Fair. Where I don't remember where he says that, but at some point he says that this stuff like costs something like $60,000 a month. So they have to like right now GitHub is spending. Let's take my name for like let's use my number. I don't remember if my number is correct. Like I would have to listen to the full talk again. At some point he does mention this, at least in passing, like how much money they spend on this. So right now, but let's assume it's 60K, okay? Right now it's 60K for this fucking search thing to work, to allow you to search across all repositories. So by the way, Pimpox is saying, I actually use the search over all repos feature. Maybe I'm a bad man, but it sometimes helps find code samples. You're using it wrong, man. You know what is the actual search over all repos for code samples feature? It's called Copilot. That's what you should be using. So obviously, so the idea is that it's not completely insane to have search across all repos. For research, you could say it's interesting. Like you can answer interesting questions about like, statistics, about trends. But as a dev on your day-to-day, you're not interested in finding all references to foo in every code base ever. And you remember in the beginning how the guy said, oh no, previous search wouldn't be able to search on forks. And now we can search on forks. Guess what you cannot search on still to this day? Try to guess. I want to see it in chat. I really want to see it. I want to see people type it in chat. Let's see if you figure it out. Oh, also let me lower the music volume. Spoons. You can search over spoons. Come on. Really? Nobody? You cannot search across branches. You can search across every single database, repository on GitHub, but you cannot search across branches in your own repository. They don't have that implemented. They do mention this at the end of the talk. They can't do branches. So yeah, right. Yeah, that would actually be useful. So like these people did not stop one fucking second to think about what is the point of what they were doing. Like, with all due respect, I'm sorry. So jokes aside, the engineering things that they point out, it's generally cool. Like the way they use probabilistic data structures for counting things, awesome. Some other tricks, like I can't evaluate everything, right? You know, there's some insight that you only gain by doing the work, but looking at the talk, it does seem very solid to me in many ways, engineering wise. But it does ultimately fail at the core goal of like you know, it's like in that meme, they were focused too much on asking whether they could do it to think about whether they should have done it. And here it's a situation where they totally should not have done it. And so right now, GitHub has to milk money from people to pay for the stupid fucking search that is useless. And you can't search across branches. So, man, fuck that. Okay, that's end of my GitHub search rant. It's like, it's insane. I highly recommend you check out this talk, watch it for real, see all the cool stuff that they build, see also the, you know, the gaping holes that are also in there. Okay, so what were we doing? All right, we were here with this situation where we kind of created a node, but it wasn't done yet, and now we're in a bad spot. And now we're in a bad spot. But this is fine, actually. Let's do new lines. Let's run the new lines test. Let's see how that one fares. Parse error, incorrectly opened comment. No? Something is out of work. Okay, so we got a new error to deal with. Like, were we even hitting that thing? Incorrectly opened comment. How do we even get there? So let's look at the tokenizer. How do we... Okay, this is the only place where it gets generated, and it's here. We got into a markup declaration open. We're expecting the next things to be a dash dash, but they're not. Then we're expecting a doc type, then I see data. Okay, so the problem here, I'm guessing, is that we have a doc type thing. So our example here has a doc type, but the matching of that thing fails. Somehow this fails. So let's add some logging in here and see. Okay, let's look at what this prints out. Next chars are empty, empty. What? Okay, this output seems sus. Okay, this one... Oh, I see. I see. But here we're searching for the dash dash. Okay, I was thinking of being clever by using dash dash. I'm an idiot. In any case, here we're looking for the dash dash. We don't find it. Here we're looking for the doc type and we don't find it, but we should find it. The problem is that we're passing in a range that is completely busted. So why are we passing in a busted range? We're calling next chars are from here, and we're passing in source, but yeah, no, we should not be passing in source. Why did I change this to as in source. This is something that is way more nuanced. This needs to be source indexed by the pointer. Something like this. False. Oh, this is still false, but it shouldn't. Should be true. Like you're searching for dog type, and well, guess what? Dog type. It's here. I wonder if source graph has that capability. Searching across branches? I don't know. I would expect them to take that kind of thing more seriously though. So I would wager yes. And actually, like something like source graph, it makes more sense for them to have like global code search than GitHub. Like it's so stupid, man, that GitHub feature. I don't get it. Branches search would be actually the best kind of use for that. Yep. Can you imagine? But sorry, couldn't fit it in. Had to spend $60,000 plus God knows how many developer hours to allow you to find every single reference of poop. You know what? Have you ever asked yourself, developers have questions. So have you ever asked yourself, how many times has poop been written in repositories? Holy shit. It was so fast. And it's an emoji. So you know what? You're actually learning something about the truth of coding. So there are 551,000 mentions of poop. Let's not forget Andrew's poop repository, which it's interesting. It's like, it's very up there, but it's not even the first result. Somehow the amount of poop emojis in here, somewhere in one Chinese Markdown file, beat Andrew. So, man, so close to becoming the poop king, but not quite. YouTube poop generator. But you know what? Let's look at code. We're not interested in repositories. We're interested, as one does, in poop mentions. But you know what? Let's do this. Const foo. Oh, it's even searching for constant foo in the vague vicinity. No, I want const foo. There we go. 800,000, almost 900,000 references to foo. Oh man, I'm gonna have to look into each one of the. Wait. So, do we stop at page 5? What's going on then? Oh, though what this search box though is nice. You know what makes it super easy to find private keys, man. Are you looking for an OpenAI API key? Chances are that you use the search and you should have a good time finding one. But then again, dude, where are my other results? Why are we even stopping at page 5? What's going on, man? Show 24 more matches. Is it because a bunch of these matches are getting grouped up? No. Like even like unless you're grouping up like hundreds of matching results that you're not showing because they're maybe in the same file. 27 more matches. It's probably limited to speed up the results. What even is the point then? I don't know, man. I'm sorry. I feel like my hatred for this thing is justified. Like, I don't want to be too annoying to people. It's not like I'm that kind of super genius. Apparently, I can't even match two goddamn strings together, but yeah. So why is my next chars are failing? You know what? Let's not name. Oh, so this was originally the code from Johnny Marler, and I might have like messed up the semantics of it. So let's do something different. Let us instead implement. Let's use the standard library. So return std dot mem dot start with u8. Haystack is source, needle is needle, and that's it. Oh, why do we need self? Self contains IDX. Oh, look at this though. So we were already slicing source using IDX. I can go to references. Okay, so what I'm doing here is redundant, and I think it's it's nicer to have that thing do it. Uh-oh. We might be looping forever. Seems that we have an infinite loop. Let's see. Is all text indexed? I don't know, but source code should be. Recent real world example. Finding an example on how to set up Snort on NixOS. Yes, I could have used the Copilot maybe. Well, technically, Copilot should be really help you do that kind of stuff more easily. We could debate, you know, to what degree it's good, but yeah, it should be able to do it for you. And to be fair, you know, I can see you having to do this, but man, Nix should be able to give you like an easy way to see which options are like exposed by a package or not. I've had this trouble also myself in the past, like trying to find information about this. They don't really document this stuff well. It's annoying. Okay, so we have an infinite loop. There is an infinite loop somewhere. That is annoying. Why is the tokenizer not making progress though? Because here we are moving the index forward. Well, you know what? I think I'm gonna call it a day. It's been fun. It's almost been 3 hours. I think it's getting close to dinner time for me. So I hope everybody had a good time. Let me see if anybody else is streaming. I'll send you all to them. I'm guessing Uninvestigate is not alive still. Sorry, live still in general. No, he's not. Okay, fine. Let's take a look at software development. What we got here. I think a bunch of people that I don't recognize. I think I'm gonna be giga lazy. I'm sorry. I should be making friends and something like this, but I also would like to send people to like a low-level programming stream, but man, all this stuff is like Nuxt, Laravel. yeah, I'll call it a day. Sorry, I'll be lazy. Thank you all for hanging out. Hope to see you soon next time. Slowly but surely, we're gonna get the HTML parser up and running, and we're gonna get good diagnostics, I promise. So, see you all. Bye bye.